हाँ तो students, now we will revise to chapter vectors. Thus, first of all, we have to define about the physical quantities. Physical quantities. Who are physical quantities? First of all, we have to define about the physical quantities. Physical quantities. So there are two types of objects present in the nature. One called physical objects and another called natural objects. That means spiritual objects. Your soul, your thought, your consider, your honesty, and other objects are the field of spiritual spirituality. But now we are discuss about the physical quantities, the quantities which obey the law of physics. What is the meaning of the obey to the law of physics? It means that if a quantity can be measured and can be weighed, can be counted, then it means it obey the physical rules. So what is the meaning of obey of physical rules? So it means if an object is able to measure, then it means that is obeying the law of physical rules. So physical quantities, the quantities, the quantities, the quantities which obey law of physics, law of physics called physical quantities, called physical quantities. The quantities which obey laws of physics called physical rules, यानी फिजिक्स के लॉ को अवे करती हैं, फॉलो करती हैं, तो ये क्या है? फिजिकल क्वांटिटीज है. So what is the meaning of obeying of physical rules? It means that can be measured, that can be count, that can be weighted. It means that is physical quantity. Is the board is a physical quantity? Yes, the board is 100% a physical quantity because we can measure to its length, we can measure to its area, to its weight, to its mass, to its density and others. So the board is a physical quantity. Is the light is physical quantity? 100% because we can measure to the intensity of light in candela. We are not able to visit to light, but we can measure to light. We can also unable to see to an electron, but we are experience to the effect of the electron, and the electron is working in the electric circuits. So that means there is an existence of the electron. So the object which is looking or not looking, if we can able to measure to that object, then it means the object is physical quantity, is in the field of physical quantity. So light and electron are also physical quantities. Air is also physical quantity because we can measure to the different density at the different pressure of air. So it is also a physical quantity. We can also measure the mass of the physical quantity. Now you should do a fill back and we measure the weight of the bag, and again we fulfill and we fill the bag by the air, and again we weight it to that object, then the mass will increase, and the increases mass from the former mass will be the mass of the air filled in that bag. So physical quantities are the quantities which obey the physical rules. It means which can be measured, weight or count. Now we are discussing about vectors and scalars. Now physical quantity is divided into two parts. Physical quantities. Physical quantities. The physical quantities are divided into two parts. The one called scalars and the others called vectors. Vectors, so these with the direction, and scalars are these which not possess direction, which has no any direction. So there are two types of physical quantity. One type called scalar quantities and the second type called vectors quantities. So the scalar quantity has only required the magnitude but not direction. Magnitude only. The scalars are represented by magnitudes only. But a vector has to obey the law of vector addition. Yani a vector possesses magnitude, a vector possesses magnitude plus direction and plus obey of law of vector addition. Vector addition. That means the physical quantity which possess magnitude as well as direction and also obey the laws of vector addition called vectors. If a vector quantity possesses magnitude and direction both but not obey the law of vector addition, then that is not a vector quantity, because that already we know that this is the north, south, east and west. If there is a wire of electric current and electric current of magnitude 5 ampere is passing inside the conductor, through the conductor, towards the direction north to south, towards the direction north to south. So the electric current has both magnitude of 5 ampere as well as the direction towards the north to south. So this follow the both condition, magnitude as well as the direction, but the electric current does not obey the law of vector addition, so it is a scalar quantity but not a vector quantity. So the thrice conditions are must. A vector quantity which possesses magnitude as well as direction and also obey the laws of vector addition called vectors. And if a vector quantity possesses magnitude and direction but not obey the law of vector addition, that is not a vector quantity. So scalars means are these without direction, the quantity which has not a direction. So that is a scalar quantity. So what is the example of the scalar quantity? Now, if you say that I walked 5 meter, I walked 5 meter, and the other body says that I walked 5 meter towards east. That means eastward. So you walked 5 meter, but in which direction? What is the direction of your working? So that is not clear. You have only magnitude 5 meter. You work 5 meter. 5 meter chale aap. So it possesses only magnitude. It has no direction. So 5 meter is a distance and it is a scalar quantity. But 5 meter in the direction of east. That means 5 meter is magnitude and eastward is the direction. So a 5 meter eastward is a vector quantity and is called displacement. A man says that a motor is going with motion 10 meter per second from a point P. A man says that a motor is going with speed, a motor is going with motion 10 meter per second from a point P. From a point P. And again, other man says that a motor is moving with 10 meter per second in the direction of east from point P. Then here the 10 meter per second only possesses magnitude but not direction. So 10 meter per second called speed and it is a scalar quantity. But 10 meter per second in the direction of east, it possesses magnitude of 10 meter per second and direction of east, so it a vector quantity. It's a vector quantity and this called velocity. And this called velocity. And already you know that displacement has a fixed direction. And always in the direction of change of displacement and acceleration is to be always in the direction of change in the direction of velocity. So they are same in the direction. So you can say that displacement, velocity, acceleration, momentum, impulse, torque and the other physical quantities every are vectors. Every are vectors. So we can write that we may define the quantities with the examples. Vectors means the physical quantities, the physical quantities which are represented by magnitude, magnitude as well as direction, as well as direction, and obey the laws of vector addition. Vector additions called vectors. What is this? The physical quantities which are represented by magnitude as well as direction and obey the law of vector addition called vectors. And the displacement, acceleration, force. But EMF, याद रखना, you have to remember that EMF, this called electromotive force, and electromotive force is the work done to move per unit charge in the total electric circuit. So EMF is a work and work energy and powers are scalar quantities. तो भले ही EMF इलेक्ट्रोमोटिव फोर्स इसके नाम के साथ फोर्स लगा है, force is attached to this name EMF, electromotive force, but it is a work and it is a work done at a per unit charge to move in the total electrical circuit. So work is a scalar quantity, so electromotive force also a scalar quantity. Nuclear force, and nuclear force has no any certain direction, so it is also a scalar quantity. So force means every type of force except to the electromotive force. Already we know that the direction of magnetic force is to be always directed towards north to south. And the centripetal force applied at a body moving at circular path is to be always directed towards its center. A weight force of that object is to be always directed towards the center of the earth. And electric force is to be always directed towards positive to negative charge. So almost every force has a certain direction. Every force possesses a certain direction and also obey the law of vector addition. So every type of force except to the electromotive force and the nuclear force is a vector quantity. And also we can take the example of momentum, impulse, torque, and others. And others. Now we can define the definition of a scalar quantity. A scalars. It means the physical quantity, the physical quantities which are represented by magnitude only. Magnitude only called vectors. Called vectors. And it has no direction and there is no any type of problem to in their addition. Because they can be added by the simple algebraic law. Simple algebraic formula. And examples are distance, because distance has no any certain direction of path. Distance and speed, time, mass, area, density, work energy, power. वर्क एनर्जी पावर तो एक ही से मतलब कि रिलेटेड है, ठीक है. डेंसिटी, मास, ठीक है. तो ये सब क्या है. अब जहां जहां आपको लगे, अब आपसे कोई पूछेगा कि इज द फाइन इज अ वेक्टर क्वांटिटी. नो, इफ द फाइन इज in the rest state, then it has no any certain direction and it is a scalar quantity. But if the fan is moving, then it possesses a magnitude. That means 10 rounds per second and in the direction of clockwise or anti-clockwise. So a moving fan possesses both magnitude as well as direction. That means 10 rounds per second is a magnitude and the clockwise or anti-clockwise is a direction. So a moving fan is a vector quantity, but fan is in rest is not a vector quantity. So we can write to the definitions of the vector and the scalars. Now we will know that how can we represent a vector quantity and what are their applications. Representation of vectors. The next topic, representation of vectors. That means how can we represent a vector quantity? How can we represent a vector quantity? Representation of vectors. A vector is to be always represented by an arrow sign. Now we can write that is represented by an arrow sign in which the length of arrow, the length of arrow shows magnitude and head shows direction. Then what is this? A vector is represented by a arrow sign. A vector is represented by an arrow sign, and the length of the vector shows its magnitude, and the head of the vector shows direction. So it is clear that if the length of the arrow will longer, then the magnitude of the object will be higher. So we can also represent that now the arrow shows V1 and V3. V1, V2, V3. Equal to T1, T is equal to T2, T is equal to T3, T is equal to T3. अब वेक्टर लॉ ऑफ एडिशन के बारे में हम समझेंगे आगे। तो अभी वहां पे अभी ये रिवाइज है, अब कितना विस्तार से ऐसे बनाएंगे आपका वीडियो देखने वाला, तो जो ऑनलाइन नहीं होगा तो उसको पूरा एकदम रेस्ट में आपको रिवाइज करना है, टेस्ट तो देना है। तो यहाँ देखना है कि ये जो एरो साइन है इसके द्वारा क्या आप मतलब कि शो कर रहे हैं। What is represented by the arrow signs? V1, V2 and V3 are representing the velocity vectors, and the length of the arrow is increasing with time. That means the velocity of the object is increasing with time. The length of arrow sign is increasing with time. It is small and at time T1 and larger at time T2 and largest at time T3, longest at time T3, then that means the velocity of the object is increasing with time. It means the arrow signs are representing the accelerated motion. What is accelerated motion? That means the velocity of the object is increasing with time. If an arrow is given of length 10 centimeter and 1 centimeter shows that a force of magnitude 5 Newton, then what is its meaning? This is north, south, east and west. This is the direction of east. So you have given that an arrow of length 10 centimeter and length of 1 centimeter shows the magnitude of force of 5 Newton, then it means a force of magnitude of 10 5 50 Newton is acting in the direction of east. A force of magnitude 50 Newton is acting in the direction of east. And is question number 2. If the length of given arrow is small and the length of the arrow is only 2 cm, and already we know that the length of 1 cm shows the force of magnitude 5 Newton, then it means 5 2 10. It means a force of 10 Newton is acting in the direction of east. Then what is its meaning? It's meaning that the longer length of the vector quantity shows the higher magnitude, and the smaller length of the vector quantity, that means the smaller length of the arrow of a vector quantity shows the smaller magnitude. So it means the magnitude of the vector is directly proportional to its length. If length of the vector increases, then its magnitude also increases. So we can represent the vector by the way, and also we can take an example. So I hope that दिख तो रहा है साफ साफ. You can write clearly. So now we clean the board. If an arrow of length 7 centimeter is given which makes an angle of 30 degree from the direction of x-axis and length of 1 cm shows that a velocity of 2 meter per second, then what is the answer of the question? It means, since the length of arrow of 1 cm shows that 2 meter per second and the length of the arrow is 7 centimeter, then it means the velocity of the object is 14 meter per second. And what is the direction of the object? At 30 degree from the direction of x-axis. From the direction of x-axis. Hence, the arrow sign shows that an object is moving with velocity 14 meter per second at 30 degree from the direction of x-axis. So, by any way you can represent and use and apply to the representation of vectors. Now we see the addition of vectors. And first of all, we revise the triangle law of addition of vectors. Triangle law of addition of vectors. Triangle law of addition of vectors. Already we know that 3 sides are required to be a triangle. Then if 2 vectors are taken and add them, then also a resultant vector is to be found. And a triangle makes with the help of thrice sides. Now you have to given that a vector A, and also you have to add the vector B in the vector A. Then what will be its resultant? Now we sketch the vector A in the same direction, in the same length, because if the length or the direction will change, then the vector will be also changed, because vector is the physical quantity which depends at magnitude of and direction, and if any one of them will change, then it means the vector will be changed. Now the matter can be understood by the example. Now we take a circular path and an object is moving at the circular path with uniform motion. And every point magnitude of its motion is 5 meter per second. 5 meter per second. That means the object is moving with the uniform speed of 5 meter per second at the circular path. Now, of north, south, east and west. So magnitude of the object is equal to everywhere, but the direction is different. Here the direction of the object is west, and here the direction of the object is south. Here the direction of object is east, and here the direction of object is north. And the direction of the object is changing at every point of the path. The direction of every the direction of the object is changing at every point of path. That means, but since magnitude is not changing, but direction is changing, so the vector is changing. So velocity of the object is changing at every point of path. That means it is the accelerated motion. Since the magnitude of motion of the object is equal to 5 meter per second at every point of path, but the direction of the object is different to the another point. So that means the vector is changed. And if you are thinking, then what is the changing from A to B? From A to B, then you can write that this may be assumed that vector VA, velocity VA, 5 meter per second westward, and this is the velocity of 5 meter per second VB in the direction of southward. So here the velocity of the object is 5 meter per second in the direction of west, and at the point P, the velocity of the object is 5 meter per second in the direction of south. So the direction is different and inclined at an angle of 90 degrees. Then what will be the change of velocity? Then now we'll discuss about the formula in the next classes. But now we can apply it because you know that already that the resultant delta V or V will be equal to VA squared plus VB squared plus 2VA VB cos 90, because the vectors VA and VB makes 90 degree to each other. So 5 square plus 5 square plus 255 cos 90 is equal to 0, and that is 50 is equal to 5 root 2 is equal to 5.414, and that is equal to 7 point something. It means the change in velocity is 7 meter per second. Say that the magnitude is 5 meter per second, and also at the point B the magnitude is 5 meter per second. Yes, but the change in velocity in a quarter distance, in a quarter part, 1/4 part of motion, the velocity of the object is to be changed by 7 meter per second. And if the object arrives from A to B in 1 second, then what is the acceleration of the object? And acceleration is equal to delta V by delta T, and rate of change of velocity. That means change in velocity by change in time, and velocity delta V, change in velocity, is equal to 7 meter per second, and time is 1 second. That means the object is accelerated by the acceleration of 7 meter per second square. So you say that the object is moving with the uniform motion. So you can say that the object is moving with uniform motion but not the uniform velocity, because the direction of the object is changing at every point of path, and velocity is a vector quantity which depends at the magnitude as well as direction. And if any one of them changes, then that means the vector will be changed. So the object moving with uniform motion 5 meter per second at a circular path will change its velocities by 7 meter per second from in quarter distance. Now, so if we have to add the vector A to vector B, then what is its law? Now, first of all, we take the vector A in the same length and in the same direction, and also shifted the tail of vector B, the tail of vector B at head of vector A. If we have to add the two vectors, then first of all we take the vector first and again uh, shifted the tail of second vector at the head of first vector, and also made the tail of the first vector to head of the second vector by a straight line, which represent the resultant vector r is equal to vector a plus vector b. We have two vectors, vector p and vector q. Then how can we add the vectors? The solution will be, first of all, we take the vector p in the same magnitude in the same direction and shifted the tail of second vector q at the head of first vector p. And now the a straight line joining tail of first vector to head of second vector will represent the resultant vector p plus vector q. So this called triangle law of addition of vectors. You can write the examples of the additions. Now we will see second collision law of addition of vectors. The addition of vectors in which a lot of vectors lie. If more than two vectors are added to each other, then this called collision law of addition of vectors. Now we can understand the addition, the type of addition by the following examples. The example is, if the vector A to add in vector B and it has to add in the vector C and also the vector D, then what has to do? So first of all we take the vector A same as the former vector and also shifted tail vector A and also shifted vector B, tail of vector B, tail of vector B at the head of vector A and also shifted tail of vector C at head of vector B and again shifted the tail of vector D at the head of vector C. Then what will be the resultant? The resultant will be the straight line, a straight line joining from the tail of the first vector to head of the last vector, and it will be represented by the vector r is equal to vector a plus b plus c plus d. This will be resultant. Now we have to add the another vectors as vector a plus vector b plus vector c plus vector e plus vector e प्लस वेक्टर एफ। अब ऐसे बहुत सारे वेक्टर्स हैं, तो क्या करना है? सबसे पहले आपने क्या लिया? वेक्टर ए, वेक्टर बी, वेक्टर सी, B, vector E, vector F, ऐसे। तो पहले वाले वेक्टर के टेल से लेकर अंतिम वाले के हेड को जो आप मिलाएंगे स्ट्रेट लाइन से, तो ये होगा क्या, तो रिजल्टेंट वेक्टर ए प्लस बी प्लस सी प्लस डी प्लस ई प्लस एफ। ठीक है, चलिए अब देखते हैं सब्ट्रैक्शन ऑफ वेक्टर्स। बस एक के ऊपर एक को रखते जाना है और पहले वाले के टेल को और सबसे लास्ट वाले को के हेड को आपको स्ट्रेट लाइन से मिला देना। और अब हम यहां देखेंगे सब्ट्रैक्शन ऑफ वेक्टर्स। In the subtraction of vectors, the vector which has to subtract is to be opposite. That means the direction, its direction is to be opposite, and again then we add according to the law of addition, and we can understand clearly by the following example. If it is a vector A and we have to subtract vector B from the vector A, then what is its solution? Now there is no any sign before vector A, it means it is positive, so we can write the vector in the same way, vector A, and the minus is change in the sign of plus, and the direction of B is to be opposite. Direction of the vector which has to subtract done opposite, and this called minus vector, called minus vector B. Now here is the sign of plus, so it will add by the law of vector addition. This is the vector A, and here is the sign of plus, so the tail of second vector, the tail of the vector which has to add is shifted at the head of the first vector. Already you know that before sometimes you know. So the tail of the second vector minus B is to be shifted at the head of the vector first, and now the straight line joining to the tail of the vector first to head of the vector B will be the resultant, and resultant will be vector A plus vector minus B. Now it can be written as vector R is equal to vector A plus minus vector B. Now we can see the other example. If this is vector A, this is vector A minus, this is vector B minus, this is vector C plus, this is vector D. Then how can do solution? The question is given here. First of all, there is no any sign before A, that means it is a positive, and the vector A will be represented as the same, and the minus will convert it into plus, and the direction of vector B will be opposite. The vector B will be minus vector B. Now the minus will be plus, and the direction of the vector C will be opposite and will be written by minus vector C, and already here is plus, so there is no any work, and the vector D will be same in the direction and magnitude. There will be no any change because the sign of plus is situated before the vector D. Now we can add the vectors by the law of vector addition, because there is the sign of plus. So first of all, we take the vector A, and again shifted the tail of vector B, tail of vector minus B, and again shifted the tail of vector minus C at the head of vector B, and also shifted the tail of vector D at vector at head of vector minus C. We know that the straight line joining to the tail of first vector to the head of last vector shows the resultant vector. That means this is vector A minus vector B minus vector C plus vector D. This is resultant vector. Now we will study about the types of vectors. चलिए types of vectors. There will be no any change because the sign of plus is situated before the vector D. Now we can add the vectors by the law of vector addition because there is Sarfaraj Ali, hello sir. Rahul Tiwari, hello sir. Stylish Anju, Sarfaraj Ali, Stylish Anju, short game. अच्छा चलिए ठीक है, बहुत अच्छी बात है। और हम लोग पढ़ेंगे टाइप्स ऑफ वेक्टर्स में सबसे पहला टाइप है इक्वल वेक्टर्स। इक्वल वेक्टर्स तो कोई दो वेक्टर इक्वल कब होंगे भाई? अरे इक्वल कब होंगे? तो वेक्टर में होते क्या क्या है भाई? तो होते हैं मैग्नीट्यूड और डायरेक्शन। अगर दो ऐसे वेक्टर हैं, इफ टू वेक्टर्स व्हिच पोसेस इक्वल मैग्नीट्यूड एंड सेम डायरेक्शन, देन दे कॉल्ड equal vectors with respect to each other. So first of all, types of vectors and the type of vectors. The first type of vector can be taken as equal vectors. Already we know that a vector possesses magnitude and direction. If the magnitude and direction of two vectors is same, it means they are equal vectors. So if two vectors if the vectors directly, a lot of vectors, if the vectors equal in magnitude and same in the direction called equal vectors, called equal vectors with respect to each other, एक दूसरे के respect with respect to each other. The vectors equal in magnitude and same in the direction. Equal in magnitude. Already we know that the length of an arrow sign shows the magnitude of a vector. Let the length of the vectors A, B and C is same and the direction is same and every are situated in the direction of x-axis. So they are equal vectors. The vectors which are equal in magnitude and same in the direction called equal vectors. Since the length of arrow of the thrice vectors is equal, it means the magnitude of thrice vectors are equal to each other and head of the thrice vectors is situated in the same direction. It means the vector possesses same direction. So a vector possesses direction and magnitude, and if a lot of vectors are equal in magnitude and same in direction, then they will call equal vectors with respect to each other. And now in the second type, opposite vectors. Opposite vectors. Opposite vectors, that means the vectors which are equal in magnitude and opposite in direction. And the addition of two opposite vectors will be equal to 0. If two men are equal in force and applying in the same opposite direction to each other, then there will be no any person will fail, and every both of palwans bodybuilders man will be equal to each other. Opposite vectors, the vectors which are equal in magnitude, the two vectors which are equal in magnitude and opposite in the direction, called opposite in the direction called opposite vectors. Opposite vectors, that means the vectors which are equal in magnitude and opposite in direction. So P and Q are opposite vectors with respect to each other because their magnitude is equal to each other but direction is opposite with respect to each other. So vector P and Q are the opposite vectors with respect to each other. And the addition of two opposite vectors will be 0 because a force of magnitude 5 Newton in the direction of eastward and a force of magnitude of 5 Newton in the direction of westward is applying at the same point simultaneously, then there will be no any resultant force will be at the point P because the both forces are equal in magnitude and acting in the opposite directions, so they will cancel to each other. So addition of two vectors will be equal to 0. So the equal vectors and the opposite vectors and their definitions are clearly by their names. नाम ही काफी है, name is enough. So now we discuss about uh, unit vector and magnitude about a vector. Unit vectors means the vector with magnitude, the vector with magnitude is to be unit called unit. That means the vector which magnitude is to be unit. That means the vector which magnitude is to be 1 called unit vector. And a unit vector is to be used. A unit vector. A unit vector is to be used to represent the direction of another vector. Direction of another vector. And there is also a definition of this vector. A unit vector in the direction of a vector is to be equal to ratio of that vector and its magnitude. And now a person said that unit vector in the direction of unit vector in the direction of vector r. Vector r. Unit vector in the direction of vector r means r cap is equal to vector r by mod of vector r. Direction of vector r means r cap is equal to vector r by mod. चलिए, लगता तो है कि स्थिति संभाल में आ गया। वीडियो लैग कर रहा है। वीडियो वाज लैगिंग बिकॉज द बैटरी ऑफ द कंप्यूटर of the system was very down, and my care was not concentrated at the computer. So my dear students, please forgive me. And now I understand that आप लोगों ने इसे नोट कर ही लिया। द वेक्टर विच मैग्नीट्यूड इज टू बी यूनिट कॉल्ड यूनिट वेक्टर, and a vector, a unit vector is to be used to represent the direction of vector. So how can a unit vector represent the direction of a vector? How can a unit vector can represent that the direction of a vector? If you move 5 meter in the direction of x-axis, then the magnitude is 5 meter, and if you have a certain direction that you moved 5 meter in the direction of east, then this is the displacement. This is the displacement in the direction of x-axis. That is displacement. So the 5 meter x-axis can be written as 5 meter I cap. So the vector quantity displacement is directed by the unit vector I cap. तो हमने जो यहाँ पे देखा, क्या देखा, चलिए यहाँ हमने देखा कि कोई वेक्टर है, वेक्टर आर, उसके डायरेक्शन में यूनिट वेक्टर पता करना है तो वो कहलाता है आर कैप बराबर वेक्टर आर बाई मॉड ऑफ वेक्टर आर, मॉड ऑफ वेक्टर आर। तो मॉड क्या है? तो मॉड को समझने के लिए सबसे पहले हम लोग बात करते हैं मैग्नीट्यूड पर। व्हाट इज मैग्नीट्यूड? So we can say that the amount of a vector called magnitude. Amount of a vector आवाज में लैगिंग है तो माइक का बैटरी भी कल से बदल देंगे, आज ही इसको हटा देंगे, बहुत दिनों से चल रहा है। This may be the cause of the lagging of the sound. Now the magnitude means amount of a vector, called its magnitude, amount of a vector called its magnitude. And mathematics is the language of physics. So we can understand about the magnitude by the examples. If a given question is find magnitude of vector A is equal to AXI AYJ plus AZK. So we can understand Find magnitude of vector A equal to AXI plus AYJ plus AZK. Then its solution is magnitude of vector A is equal to mod A. Mod A means under root AX squared plus AY squared plus AZ squared. It means A is equal to under root AX squared AY squared plus AZ squared. This is the magnitude of vector A. ठीक है? This is the magnitude of vector A. Now, again the question is find magnitude of vector P is equal to 3I plus 4J plus 5K. Then what will be its solution? Its solution will be magnitude of vector P is equal to mod of P. Mod of P means 3 square plus 4 square plus 5 square is equal to under root 50 is equal to 5 root 2 is equal to 5 into 1.414 is equal to 7 point something. That means 7 units. 7 units. Again the question is magnitude of vector A is equal to 3I minus 2J plus 1K. Then what will be the magnitude of vector A? Magnitude of vector A will be mod of A. It means 3 square plus minus 2 square. Minus 2 square. Because the number minus 2 is joined with the J cap. So minus 2 and the square of minus 2 will be plus 4 because the magnitude can't be negative. Magnitude can't be negative. And plus 1 square. When we take the magnitude of a vector, then we remove the sign of arrow. That is A. It means 9 plus 4 plus 1. That means under root 14 unit. This is answer. First of all, we have to understand how we remove the sign of arrow from a vector. Now, write we position vector of a point P. This is the x-axis and let a because the number minus 2 is joined with the J. This is origin and this is the x-axis and y-axis. Let a man starts to move from the origin and appear at the point A 3 meter. Appears at the point A 3 meter. And again it moves towards y-axis. Towards y-axis. The vector P can be written as, vector P may be written as 3 meter I cap plus 4 meter J cap. Plus 4 meter J cap. Now the P possesses a sign of vector. It is written as 3 meter I cap plus 4 meter J cap. This is a vector because it possesses magnitude 3 meter and direction in the direction of x-axis and again magnitude 4 meter in the direction of y-axis. So this is the x-axis and this is the y-axis, and if already we know that the position vector of the point P 3 meter I cap plus 4 meter j cap, it means we can reach to the point P, because first of all we will appear at the origin O. We will appear at the origin O and travel the distance 3 meter in the direction of x-axis, and again 4 meter in the direction of y-axis. Then we will reach at the point P 3 meter I cap plus 4 meter j cap. So if it is a vector and the sign of arrow is situated upon P, it means we can reach to the point P. And if we take the magnitude of vector P, it means mod of vector P. It means under root and sum of a square of 3 and 4. It means P is equal to 25 and P is equal to 5 meter. If anybody says that a point P, if you don't know that where is point P, and a body says that a point P is situated at distance 5 meters from the origin, then where is the point P? In the direction, in which direction? Then if we take the magnitude of a vector, then the direction of the vector is to be destroyed, and we cannot appear to that the point P, because we have only magnitude but not the direction. So if we have to go to Delhi, then if we have magnitude only but not the direction, that what is the direction of the Delhi from where we appear, so we cannot reach to that point. So if we take the magnitude of a vector, then its direction is to be removed. So we remove the sign of arrow from a vector while taking magnitude of the vector of a vector. What is looking here? No sir, all is right. सरफराजी, चलिए बहुत अच्छी बात है. अब यहाँ पर जो हम देखेंगे क्या, तो क्वेश्चन है. अब एक और बात है कि एक क्वेश्चन हम लोगों ने देखा था क्या, कि फाइंड मैग्नीट्यूड ऑफ वेक्टर A इक्वल टू ax I कैप प्लस ay j कैप प्लस az k कैप. और what is the magnitude of the vector? Is the sum of a square of component of x, y and z. So a is equal to under root ax square plus ay square plus az square, from where the formula is found. So now we take that we have to measure the distance of this point to this point, यानी ये वाला जो करना है उससे इसको मिलाना है. तो what will be this side, what will be the length? तो इसके लिए हम लोगों को पहले ये स्क्वायर प्लस ये स्क्वायर, तो ये मिलेगा ये स्क्वायर, और ये स्क्वायर प्लस ये स्क्वायर, तो मिलेगा ये स्क्वायर. ठीक है, तो एक्स स्क्वायर प्लस वाई स्क्वायर इक्वल टू ये स्क्वायर और एक्स स्क्वायर प्लस वाई स्क्वायर इक्वल टू ये स्क्वायर यानी जेड स्क्वायर इक्वल टू ये स्क्वायर। ठीक है, चलो ऐसे भी बता देते हैं। आप भी क्या कहोगे कि क्या क्या बात है, क्या तुम भी कहोगे क्या बात है भाई। इसको भी हटाते हैं, चलो क्या बात है। इसी में हम देखते रहते हैं कि आपको कैसे दिखता है, सब आपका कमेंट है। अब यहां से दिख रहा है, अब इस कॉर्नर से इस कॉर्नर का लेंथ हम लोगों को मेजर करना है, यहां से यहां तक। तो क्या करेंगे यहां से यहां तक के लिए, तो सबसे पहले इसका स्क्वायर फिर इसका स्क्वायर, तो इसका स्क्वायर करेंगे और इसका स्क्वायर करेंगे तो इसका स्क्वायर मिलेगा, और इसका स्क्वायर करेंगे और इसका स्क्वायर करेंगे तो इसका स्क्वायर मिलेगा। तो ये एक्स स्क्वायर और प्लस वाई स्क्वायर, तो ये इतना का स्क्वायर यानी एक्स स्क्वायर प्लस वाई स्क्वायर और प्लस जेड स्क्वायर, तो इतना का स्क्वायर। ठीक है, अब देखिए घूम रहा है आपके सामने, नेट का प्रॉब्लम थोड़ा चल रहा है, ये वो सिस्टम में जुड़े हैं, घुमरी आ रहा है। नेट वाला कोई नहीं छोड़ छाड़ किया है, ठीक है, सब कहानी बेहतर बढ़िया जबरदस्त है। क्या कर भाई, चलो हम अपना मोबाइल भी बंद कर देते हैं। और इसका कोड भी किसी को पता नहीं, ये नहीं कि कोई जुड़ भी जाएगा गलती से, तभी इतना घटिया सर्विस है BSNL वालों। तो ये आप समझ गए कि इसका स्क्वायर और इसका स्क्वायर और इसका स्क्वायर। ठीक है, नाउ वी विल डिस्कस अबाउट द यूनिट वेक्टर एंड कम एट द फॉर्मर टॉपिक। मुझे लग रहा है कि लाइट की कमी है, मैं थोड़ा लाइट को बढ़ा के आता हूँ, 1 सेकेंड लगता है उसको चेंज करने में। Distance of this point to this point to this point, ये वाला जो कर्नल है उससे इसको मिलाना। What will be this? What will be the? तो इसके लिए ठीक चल रहा है। ये स्क्वायर प्लस ये स्क्वायर तो ये मिलेगा ये स्क्वायर। Now a buddy asked to me that the question find unit vector in the direction of vector A is equal to AXI plus AYJ plus AZ. And unit vector in the direction of vector A. Then the unit vector in the direction of vector A is equal to A cap. A cap means vector A by mod of vector A. This means vector A cap is equal to vector A. Vector A is AXI, AYJ and AZK, and mod, that means the magnitude of vector A is AX square plus AY square plus AZ square. And the equation may be written as A cap is equal to X by under root AX square AY square plus AZ square I cap and AY by under root AX square plus AY square plus AZ square and AZ by AX square plus AY square plus AZ square K cap. तो ये now we can write the unit vector in the direction of vector A partially by parts along the x, y and z axes. If the new question is find find unit vector in the direction of vector p is equal to 3I minus 4j plus 2k, then the unit vector in the direction of vector p is p cap is equal to vector p by mod of vector p. Vector p means 3I cap minus 4j cap plus 2k cap by mod of vector p is the sum of a square of component of I, j and k. 3 square plus minus 4 square. Here the minus 4 is the component, is the magnitude of y component j. So it is taken minus 4 square plus 2 square, and that is 3I cap minus 4j cap plus 2k cap by under root 9 plus 16 plus 4. So the vector p cap is equal to 3 by under root 29 I cap minus 4 by 29 j cap plus 2 by 29 k cap. So we can find the unit vector along the direction of a vector. Now students, we will discuss about the next part of vector as position vector, collinear vector, co-initial vectors, co-terminus vectors, null vectors. Now we discuss about the vector position vector. Position vector. It is clear from this name that it represents the position of a point. That means the vector which represents or shows the position of a point, the position of a point called position vector of that point, called position vector of that point. Let this is the point P. This is the point P, and we have to write the position vector of the point P. Then we will consider about the this y-axis and z-axis, x-axis, y-axis and z-axis. This is the origin O. And now we meet the point O to P. Point O to P. Take the name of the vector, vector R. This is called OP. OP is equal to vector R, if the position is x, y and z. That means the point P lies at distance x from origin at x-axis and y from origin at y-axis, and the point z from origin. Then the OP is equal to R may be written as x I cap plus y j cap plus z k cap. जैसे अगर यहाँ है 3, 4, 5, इसका मतलब x एक्सिस पे 3 मीटर, 4 एक्सिस पे x एक्सिस पे 3 मीटर at x एक्सिस, 4 मीटर at y एक्सिस and 5 मीटर at z axis. That means the point is separated at distance the point is separated at distance x from y and y from x. So now the component is 3, 4, 5, and the equation may be written as 3 meter I cap plus 4 meter j cap plus 5 meter k cap. So OP is equal to vector R. That means written as x I cap plus y j cap plus z j cap unit vector of point P. Unit vector of point P. Unit vector नहीं, position vector. Position vector. So OP is equal to R called position vector of point. Now we discuss the displacement vector. What is the displacement? Already we know that displacement is the straight line joining two points. What? तो the straight line joining कितना मिनट चला अभी तक नहीं दिख पा रहा है, साफ चल भी नहीं रहा है. The straight line joining two points or the minimum distance between two points called displacement, and it is your battery is, you might want to plug in your PC. अरे भाई पीसी में तो ओहो, एक वो याद करते हैं, ये वो गड़बड़ा जाता है. चलो डिस्प्लेसमेंट का तो आप डेफिनेशन में तो ऑलरेडी जानते ही हैं. द स्ट्रेट लाइन जॉइनिंग टू पॉइंट्स कॉल्ड डिस्प्लेसमेंट, या द मिनिमम डिस्टेंस बिटवीन टू पॉइंट्स called displacement. And now we have to represent the displacement vector in the form of unit vector. Now we consider that a point is situated, an object is situated at point A and it moves some area, and lastly it at point B. Lastly it arrives at point P. So the straight line joining A to B, is the displacement of the person, of the object. Now we can locate the point A and B in the form of unit vectors. This is the x-axis I cap, this is y-axis j cap, and this is the z-axis k cap. This is the origin of the coordinate system. Let the position vector of point A is r1. Position vector of point A is r1, and position vector of B is r. Let the position vector of A is x1, y1, z1. It may be written as x1 I cap plus y1 j cap plus z1 k cap is equal to r1, and this is r2 is equal to x2 I cap plus y2 j cap plus z2 k cap. So in in triangle OAB, OAB, OA plus AB is equal to OB. OA plus AB is equal to OB. OA plus AB is equal to OB. तो ये हो जाएगा AB इक्वल टू वेक्टर OB माइनस वेक्टर OA. तो AB is displacement represented by vector D and OB is vector R2 and OA is vector R1. So here D is R2 is equal to R2 position vector is x2 I cap plus y2 j cap plus z2 k cap and minus x1 I cap plus y1 j cap plus z1 k cap and D is equal to x2 I cap plus y2 j cap plus z2 k cap minus x1 I cap minus y1 j cap minus z1 k cap and the D is equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. This is the original form of the displacement vector in the form of I, j and k, in the form of unit vectors I, j and k. So the displacement vector may be represented by the x2 minus x1 I cap, y2 minus y1 j cap plus z2 minus z1 k cap. So the student, now we will fulfill the vector in the next episode because the camera is down. Just show this is cut, this